我们讲到的是 ，OK， let's say we have a let's take the Earth. How does an object achieve orbit? And what is an orbit? Basically, it is a circular motion around the Earth. So let's say satellite orbit, it is the circular motion of the satellite around the central object, which is the Earth lah. Right? So let's say, and the way to think about it is like this. Let's say 你的 satellite 本来是有 certain velocity v in a certain direction. Okay? So this v, it happened to pass by the Earth, and then the Earth exert a gravitational force on the satellite because the satellite has entered the field of the Earth. So now you have a force, I will label this towards the center. Now, every time the satellite tries to escape, it is pulled by the force closer to the Earth. So that means this one, initially the velocity is going in this direction. Now, because of this force, it has pulled towards like this. So now your velocity direction has changed to this direction. And then continue. 现在那个 satellite 它走向这个方向，它要 escape 从这个方向。每当它一要离开，它也是给这个 force 拉回来，所以这里也是这样子。This goes on repeat. Every second there is a force pulling it, and this force is 90 degrees to the velocity vector. This force here, always pointing to the center. Here again, I have the force pointing to the center. Okay, so if I complete the trajectory, if I complete the diagram, this one goes like this, like this, like this, this, like this. This one, it goes one revolution, one rotation around the Earth. Notice that the satellite always tries to leave the Earth, but the Earth always tries to pull the satellite. So from there, they find a balance. The satellite is traveling at very high speed. This is a very large velocity. But this velocity is large enough to keep it floating, not falling towards the Earth, but small enough to prevent it from drifting away. That means from there they find a balance. Understand? From there they find a balance. That means the gravity, this force, is not enough to pull it down to the Earth. And then the velocity is not enough to escape away. They balance, so the satellite goes in orbit. That is the reason. That is how an orbit is formed. Okay? Okay? Let me know if you don't understand, let me know. Okay. If I mix English and Chinese, okay, but I don't use Malay, okay? All right, now, so here is how a circular motion is formed. That is first thing. A circular motion is formed because of what? Because of this force. 因为你有这个 force, 你才有 circle. Imagine 如果我把这个 arrow 放小, I make this arrow very, very small, then you get a very smooth circle. Okay, that is an orbit. Now, how an orbit is formed, I will write down here. An orbit is formed is because of a force. What is this force? Gravitational force. We also call it, in circular motion, we call it centripetal. Okay, centripetal force. Centri 也就讲 rotation 的意思啦。你要有 centripetal force， 你才会有 circular motion。所以在这个情况里面呢，就是你的 centripetal force 是谁给的？这个就是 gravitational force 给的。So the centripetal force is the gravitational force. Is the gravitational force. Okay. Now, point number 1. In the note, in an orbit, The orbiting object is traveling with a certain velocity v that is large enough to keep it from falling towards the central object and small enough to prevent it from drifting away. Okay. Now, point number two, the orbiting object is moving in circular motion. The force acting on the object is called what? Centripetal force. In an orbit, the gravitational force provides the centripetal force. Okay, hence equating gravitational force to centripetal force. 因为 gravitational force 就是 centripetal force， 所以我们把它们两个 equal。gravitational force 的 formula 是什么？这个是 gravitation 的第一个 part 已经讲到 F 等于 G m1 m2 over r square。这个是我的 gravitational force 的 formula。之前你们学的是 F 等于 mg， 这个是比较 general 的，这个只是 apply for object very close to the surface of the earth. But in general, it's this one. Okay, so we will use this force here. Now, centripetal force, the formula is F equals to mv squared over r. We got two formula here. Okay. Now, here we will not discuss the derivation of this one because it will never be asked in SPM here. But understand that this is, we got these two forces, they are equal, right? So I can equate them. 我把它们 equal 起来 ，Gm m1 是我们 OK， 我可以把它放去大 M 啦，大 M， 然后这个是小 m， 大 M 就是 let's say 我讲 Earth 跟 satellite， Earth 跟 satellite， 大 M 就是 Earth 的 mass， satellite 就是小 m 啦 ，OK like this one。So Gmm over r square 等于 mv square over r。这个 cancel， 我拿到 Gm r square equals to v square over r. Okay, then here both times r cancel. This become what? V square 等于 Gm over r, and finally square of Gm over r. We get this one. 这个是什么来的？ This one, the v, we call it the linear velocity or the linear. In your textbook, the KSSM textbook, it says linear speed. You can call it linear speed or linear velocity. It is how fast the satellite is moving here in an orbit. If you are asked to calculate how fast the satellite is moving, then you will use this formula. G 是那个 constant 啊 6.67 乘10 power of 11. This is a constant. 大 M 是什么？ This is the mass of the Earth. What is the R? This is the radius or the distance. Now 这个 R 要小心啊，很多人弄错啊。这个 R 是 distance 从哪里去哪里？从 satellite 的中心去到 Earth 的中心。OK， 去到 Earth 的中间。意思说，如果 question 给你 altitude。Let's say 它给你 altitude 是20200 km， 这个是 altitude。OK， 我有一个 satellite 是在这一个高度 altitude， 然后我要算它的 speed， 我直接把这个放进去来吗？没有啊，这个你还要加什么？你还要加你的 Earth 的 radius， 因为它是从 Earth 的 center 开始算起，去到那个 satellite， 所以你要拿 altitude。加你的 Earth 的 radius， 那个才是我的 R。Okay? 因为 altitude 是 measured from surface， 我们加 h 吧 ，from surface of the Earth， 然后我们还有一个 distance 这边是 radius of the Earth。Okay, so 这个 R is right here is R plus h。 Yeah, so this one, okay, put it in your note number 2. Okay, copy down and put it in number 2. And then example 1, find the speed of the satellite orbiting the Earth at an altitude of 20200 km. Okay, you try calculate that one, example 1. Example 1， 你要找的就是如果它有一个 satellite， 它的高度是多少？从20200 km。This is altitude from the surface of the Earth. Then 你要找如果这样高的 satellite， 它的 speed 是多少？它一定要 move 在什么 speed to maintain 这一个 altitude？ 我们可以找出来，我们用这一个 formula。So V equals square root of gm over r. G is 6.67 times 1011. The mass of the Earth 5.97. And then divided by, okay, the distance r. So you take this one, 你要换去 meter， 一定要换去 SI unit. So 20200乘10 of 3， 然后你还要再加它的 Earth 的 radius， which is 6400 km， 也是要换啦，6400乘10 of 3。 Okay, what's the answer? OK，你是加一个的，stop stop就是你算了，然后那是你算到5个，然后我 store 它在一个柜子先，柜子之后我可以拿出来用，所以我会按 Shift 按 Cell，我 store，那你看你 store 在哪一个位置？这边 A B C，所以你算了的时候，你就不用写在那，你 store 在那个 calculator，然后你再。Okay, the rest you check your calculation. Sometimes this one may seem like straightforward, but when you press the calculator, sometimes you get the wrong answer. So you check your answer. This one should be 3.87. Because you are dealing with many large numbers and many power also. 3.87乘10 power 3 meter per second. Check if you get this one. Okay. Especially Edmund, check your calculation. Let's say 你缩写是新的啊，缩回去是会多对，我真的我先算上面。The bottom one. So,是第二个，我不要弄成第一个。然后呢，上面是下面。 3869.09，也就是你拿到3869.09 meter per second。哎，这个小数点你可以把它放起来，所以是3.8869乘10^3。或者我写3.87了，3.87乘10^3。OK， 有问题吗？可以。OK，so 你算到的 velocity， 那这个是什么意思？3.87乘10^3，可以3870啊，3870米在1秒，这个就是那个 satellite 的 speed， 在这一个高度。OK， 所以你算到的这个 speed， 如果那个 satellite 它没有 travel 在这个 speed，let's say 它的 speed 是低过这个了 ，let's say 它的 speed 是3000。If the satellite is moving at 3000 less than this speed, what happened to the satellite? The satellite will slowly lose altitude. It will go like this, lose altitude, and then it will eventually go towards the Earth like this. That means this one is the required speed. Okay, the required speed for the satellite to maintain at the altitude. Understand? Okay, that is the speed for the satellite to maintain at that altitude. If you travel less than this speed, then the satellite will spiral inwards. Okay, 它会慢慢 lose altitude. 它一 lose altitude 的时候，它开始进入大气层。它一进入大气层 ，there's air resistance, more air resistance, and then it will further slow down the satellite, and then the satellite will crash into the Earth like this. Okay, so if you want to maintain the satellite here orbiting, you have to make sure your satellite is always moving at this speed. Cannot be smaller, cannot be greater. 如果是 greater than this speed, then 会怎样？ If the speed is greater than this one, then the satellite can escape. It will escape. Okay, it cannot maintain at this orbit. Any problem? 没有，刚刚你看那个咖啡这样子 ，OK？ 我来重算 ，Yeah。OK， 来next one 啊 ，So next one the next page, look at number 3. So what does this formula tells you? V 等于 square root gm over r 对吗？这个是 constant， 这个是 constant。如果 r increase，v 会怎样？这个是在分母。如果 r value 大的话，这个就会变小。所以这个跟你讲，如果你的 satellite 越高，你需要的 speed 越低。Again, if your satellite is very high, is very far from the Earth, the speed required to maintain the orbit is lower. You don't need as much speed. 如果你把它if you think of it logically, 你越靠近地球，你的那个 gravity 越强，所以你要跑得越快。你越离它越远，你的 force of attraction 比较小，所以你不需要这样大的 speed 来 maintain orbit。OK， 所以如果你的 satellite 越远，你的 speed required 是越低的。That comes to point number 3, right? So point number 3, satellite in higher orbit need less velocity. Satellite in lower orbit, they need more velocity. And point number 4, also we talked about this one. If the linear velocity is less than the required linear velocity, the satellite will fall to a lower orbit. And if the linear velocity is more than the required, then the satellite will climb to higher orbit and it will eventually escape. All right. Now let's go to the next part. The time period of satellite. What is the meaning of period? What is period? Period is time taken for one cycle, okay? Time for one cycle. What is the period for Earth? For one cycle of orbit. The Earth orbit the Sun every 365 days. That's 1 year. So the period of the Earth is 365 days. Okay, so time for one cycle. Now, to calculate the period, let's see, what formula do we have? From just now, our formula, 刚刚我们那个 V V 等于 square root of GM over R。我们从这边我们拿我们的 period，OK， 怎样？那这个 V 是 velocity 对吗 ？velocity 也就是 distance over time。如果我的 satellite 是走圆圈，这样我的 distance travel 是什么？那个 circumference。distance travel 也就是我的 circumference， 所以是 2 pi r， 这个是 distance。time 呢 ？time of one cycle 就是我的 period， 所以我写 distance 是等于 2 pi r，time 是等于大 T， period 的 symbol 是大 T。OK， 所以 velocity 我可以把它写成 distance over time。And then this is 2 pi r over capital T equals to square root of GM over R. OK， 现在我要的 formula 是 T， 因为我要 period 找 period 嘛，所以我的 formula 一定是要 subject 是 T， 所以我这个我先把它调转 T over 2 pi r 等于这个也是调转 R over GM。Like this. Okay, this one you put in point number 5, you copy in point number 5. And then move the 2 pi r, T equals to 2 pi r square root of R over GM. Now, 接下来把这个 R 放进去 2 pi， 然后要做这边吗？这边那边可以啊 ，OK。2 pi， 然后这个我可以写 square root of R over GM， 再乘 square root of R squared。这个从哪里来的？这个是从 OK， 我这样子放了 R 乘 R squared。OK， 这个从哪里来？这个是从这个来，就把它想象成 reverse 啦。如果我的 R square， 我 square root 过后变去 R， 我放在外面，我把它放回进来就是 R square。OK， so this one and this one become 2 pi square root of R cube over GM。OK， 我们到这边，这个就是你的 period equation。这边 OK 吗 ？OK， so 把 R 放进去 square root， 所以你拿到 R square。这个乘起来，你拿到 R cube。So T equals to 2 pi. You will see this equation. This is when you need to calculate the period of what? Of the satellite. Okay. So what do you need? Period of satellite. Satellite period。这个是什么 ？m 是谁的 mass of Earth。这个是 distance 啦。Okay, now using this equation, you try example 2. Calculate the height of a satellite that has a period of 24 hours. So, example 2, it says that if I want the satellite to be 24 hours, 意思说我要 send 一个 satellite， 我要那个 satellite 它 round 那个地球每24小时，也就是它的 period 是24啦。time for one cycle 是24小时，所以我要那个 satellite 的 period 是24小时。Then 我应该要放它几高 ？How high I have to put it to get the period of 24? This is example 2. We will calculate using this one here. Period 的 unit 是在 second 啊，记得啊，所以24 hour 你要换去 second 啊。我放进来的时候是24 hour 乘以3600 second 等于2 pi square root of RT OK， 这边搬过去 square 13750 square 就是 RQ。Then this one move. OK， 所以这个是答案吗？这个不是答案啊，因为他要的是 altitude， 你的 R 是这边，所以你要减掉 of the radius， 你才可以拿到 altitude。H 等于 R 减 radius of Earth。真的。有时如果太多是，你可以分开来算啊。如果你一次过算，可能会容易出错，所以有时候你分开来算也是可以。OK， 我们拿到的 altitude 是35800 km， 意思说你的 satellite 你要放它几高？你要放它在35800 km， 你的 satellite 才会绕地球一圈24小时。OK， 所以用这个 formula 你可以 calculate any period you want, then you find the height. Where should you put the satellite? The satellite that orbit the Earth every 24 hours. What do we call that satellite? This satellite is called a geostationary. Geostationary satellite. 什么意思是 geostationary？geo 就是地球 ，geo is the earth。stationary 是说 not moving。它的意思是讲，这个 satellite 可以 focus 在地球的某一个 location。When the Earth spin, the satellite follows it. That means 24 hours 24小时那个 satellite 都是 focus 在同样的一个 location。我们叫它 geostationary satellite。它怎样？每一时每一秒都是 focus 在同样的一个 location， 因为它的 period 跟 Earth 的 period 一样嘛。你看啊，我这边我画 ，OK，let's say this is the Earth。Okay, this is the Earth, this is you. After 24 hours, where will you be? You are here. After 24 hours, you come back the same spot. Right? Because here, 24, if we divide by 4, after 6 hours, you will be here. Yeah. This is after 6 hours. Another 6 hours, where will we be? We'll be here. Okay. Another 6 hours. Another 6 hours, you are here. And then 24 hours, you come back. You come back same location. This is 124 hours, right? The Earth goes 124 hours like this. 所以如果你的 satellite 的 period 也是24小时，将那个 satellite 在你的头上，它6个钟过后，它也是去这边。Okay? Because the satellite also has the same period, 6 hours. 6 hours, the satellite is here. 6 hours, the satellite is here. 6 hours, the satellite is here. So every single minute passed by, the satellite is always above your head. 这个 satellite 我们叫它什么 geostationary satellite， 因为它 focus 在同样的一个 location。你几时每时每刻你看上面，你就看到那个 satellite。24 hours, okay? That is geostationary. What is the use of geostationary satellite? GPS, okay? TV, all this. You don't need to position your antenna. If you want to receive signal from the satellite, you do not need to change the antenna direction. You can just point at one direction. I change this to the antenna. This one, I just point the axis, I point to the satellite. Whenever the rotation is, this is always in line like this. I do not need to change the antenna. So that is the use of geostationary satellite. If your satellite has a different period, the satellite is moving, sometimes it's faster, sometimes it's slower, then you have to position your antenna. Okay, so here we only fix at one location. The location is called geolocation, stationary satellite. Okay. I remember GPS is non-geo. GPS is non-geostationary. Is it? Okay, then I made a mistake. Should be TV or the other signals. Okay, other. The textbooks write like this. Okay. All right. Okay, this one can. All right. So example 3. Example 2 we already did, right? Okay, you do example 3. Same formula, we use this one.我的这个 formula， 如果我算 satellite 是，我算 period 的 satellite，then 我的 mass 是什么 ？Earth 对吗？意思说这个 m 是 always for 那个 central object。This is the central object。因为在每一个 orbit， 你一定是有一个 central object， 然后你有一个 orbiting object。这个 m 是给那个 central object 的。所以如果你看 example 3是，他讲 in order to keep a small satellite drifting into a nearby asteroid, it is placed in an orbit with a period of 3 hours and radius of 2 km. What is the mass of this asteroid? That means you want the satellite to orbit around the asteroid. So you're going to change the Earth to an asteroid. Okay, taking the satellite orbiting around the asteroid. So you will take the mass here as the mass of the asteroid. Here, this is the mass of asteroid. 因为这个 formula 不只是 apply 在 satellite Earth， 你也是可以 apply 在Earth 跟 Sun。OK， 你可以算 Earth 的 period， 你就要用 Sun 的 mass 咯。你用 Mars 的 period， 你就用 Sun 的 mass。OK， 所以我可以用 satellite 跟 asteroid。他讲 radius of 2 km， 那个 radius 我们需要加那个Earth 的 radius 吗？已经是算进去了的。sorry， 不是 Earth， 是那个 asteroid， 它已经是算进去了。那个2 km 已经是那个 distance total 了。 Okay, any question? Okay, a few points on the geostationary. You can look at number 6. So the geostationary satellite is satellite that has a time period the same as the Earth, 24 hours. And 7, the height of a geostationary orbit. How high is it? Just now we calculated, right? 358,000 km. Oh, sorry. This is 358,000 km. This is the height of the orbit. Number 8, it is always above the same geographical location. Number 9, it is located exactly radially above the equator and has the same axis of rotation as that of the Earth. What does it mean? 它的 OK， 你知道它的高度，可是它是 place 在哪里呢？这个是你的 OK， this is the Earth. The Earth is the axis of rotation is a bit tilted like this. The equator, this is the equator. Okay, let's say this is the equator. And then if I draw like this, hopefully the diagram makes sense. Okay, so your satellite is somewhere here above the equator. So this is the equator. It is directly above radially. That means in the same plane as the equator, like this. That is where the satellite is placed. Not only it has a period of 24, it is placed above the equator, radially upward, so that the rotation of the satellite share the same axis as the Earth. This is the rotation axis. Rotation axis. The Earth rotates around the axis. The satellite also rotates around the axis. They share the same rotation axis. Yeah, so next one we go escape velocity. Okay.那班上有多少？31个人，然后有多少班？30啊，就是拿 physics 的，拿3个 science 的。一般吧，就是你们的班吧，其他的班是拿 business 啊、commerce 啊。Okay, like this is the final one. What is the meaning of escape velocity? If you look at the textbook, it says the minimum velocity to escape from the gravity. That is not clear enough. Okay, see. Here, we have the Earth. Let's say, 我丢一个东西 vertical, okay, 我丢它 vertically upward. Like this. I throw it with a velocity of 100 meters per second. U 100 meters per second. The object start rising. What happened to the velocity? The velocity will start slowing down, right? Because you have what? You have acceleration due to gravity. Your acceleration due to gravity downward 多少 9.81 对吗 ？OK， 我们放10 ms minus 2， 意思说每一秒你的 velocity 会减色。OK 啊，我丢它100，每一秒它会减色。10秒过后，它在这边。它的 final velocity 是0 meter per second. This is after 10 seconds. All right. So if I ask you what happened the next second, after 10 seconds it is here, right? But then 11 seconds, what happened to the object? Where is it? The object will start coming down because you still have gravitational acceleration. Right? So the object reaches 0 and then it starts come down. So this object then reverse direction, come down and then fall back to the ground. Is this escape velocity? This is not escape velocity because I give it 100 meters per second, but it still come down. This is not escape velocity. Now I try harder. I throw the same object, but I give it larger velocity. Okay, I give it 1000 meters per second. Here, again, 1000, it takes how long? This one takes 10 seconds. Okay, this one takes 100 seconds. 100 seconds until here, the velocity becomes 0 again. When the velocity becomes 0, then 我们会看它在哪一个 location， 它是不是在很高，还是它还是很how far is it from the Earth? Okay, so at this location, if the g is still 10 meters per second minus 2, what happened to the object? Again, the object will fall back down. Okay, because you still have gravitational acceleration. As long as the gravitational acceleration is there, you will always come back down when your velocity becomes 0. Understand? Okay, so far okay? Following? Okay. Okay. Let me know if you want me to clarify again. Now, this time I say 1000 is not enough. 我要再丢. Okay. I use a lot more, I add a lot more velocity. Now this time the effect start to become a bit significant. 开始有一点效果 OK 从这边开始你知道我们的 G 是10对吗10 ms 减2如果你的 altitude 很大的话你的 G 会开始减少10 9 8 7 somewhere here become 4 meters second minus 2这个 altitude 要几大我们不是讲100 km 100 km 你的 G 还是10 100 km from 那个 ground 呢这个是 ground 我们现在的 level 100 km 你的 G 还是没有什么变的还是10我们是讲着几千几百几千 km then it start to this one will start to change OK 所以你的 G 开始边去减少4 OK 在这边我丢我的东西我丢我的 object 上到来这边它的 velocity 变0它会掉回去吗你还有 G 吗如果你还有 G 你这个也是会掉回去 Okay, if you still have the gravitational acceleration, you will fall back down. Okay, now I try one last time. I throw it so hard that when the velocity becomes 0, okay, u 我给它 certain velocity u， 然后 after certain period of time， 它的 velocity 变 0， 在这个 location 的时候，它的 g 刚好 hit 0了，就是它刚好出了那个 gravity 的那个 field。Then what happened to the object here? The g is 0, there's no acceleration. The v is 0, there's no force acting on the object. Then what happened to the object? The object will float at this location. It will not go anywhere. It will just float there. Because there's no force and there's no velocity also. It cannot go any further, right? 它不可以再继续跑，因为它已经没有 velocity 了。它也是不会回头啊，因为它都没有 g 了啊。所以它的 object 会做什么？它在这边 it will float in the space. It will float. Okay, it will not go out or in. No. Okay. Now， 如果我再丢多一次，大过这一个，我们叫这个 U4 了。1、2、3、4 ，this is U4. Let's say 我丢 U5， OK？ 我丢 U5 是大过 U4 的 ，OK？ 大过 U4。Then 这个 object 会做什么？当它到 G 0的时候，它还有 velocity。Let's say it has 5 meters per second. OK？ 这个 U5 大过 U4， 很大的 velocity。当我丢到它上面 ，G 变0的时候，它还有剩下的 velocity， 它还有5。这样它会做什么？它会继续跑哦，它会 escape. It will escape from the earth. And when it escape, it keep going. It will never come back already. Right? Because nothing is there to slow it down. So here's a question. I got so many U, right? U1, U2, U3, U4, U5. Which one is the escape velocity? Which one is the escape velocity? Is it U4 or U5? Answer is U4. Okay, U4 is the escape velocity. Why? Because escape velocity is the minimum velocity required to just escape. We don't want any leftover. This one got leftover. This one has no leftover. So we say that U4 这个是我们的 escape velocity. How much is this? Let's say this one is 1000 kms. Okay, too big. Let's say I just take one example, 11 kms. This is 12 kms. This is velocity, escape velocity. This is not escape velocity. This is already higher than escape velocity. Okay, so remember your escape velocity is the minimum velocity to let it just to make the object never come back. Yeah. Okay, so I will make a statement to define escape velocity. I will write it down here. So escape velocity of a planet. Escape velocity. Is that minimum velocity? Wait, is it in your note? Oh, it's already in your note. Number 10 lah, note number 10. Escape velocity of a planet is that minimum velocity given to an object on that planet due to which it will not come back again. Okay. Now, 现在我们要拿一个 equation 来算我们的 escape velocity. So what will be our equation? Okay, point number 11. Okay, write down under point number 11, the potential energy of the object at large distance from the surface of the planet is given by. Now, 你的 potential energy 是什么 formula？ 有学过 potential energy 吗？有吗？Jasmine， 你们有学到 potential energy 吗？在可能之前或者什么 ？The formula for potential energy is this familiar to you? PE equals to mgh. Yeah, I just want to know, is this familiar? 你有看过这个东西吗？如果有看过，给我知道；如果没有，也是跟我讲，因为我要知道我要不要 include 在这边。Okay, have you seen this? Never. Okay. Just mean say. Got say out a bit. Say out a bit. Say out a bit. Okay, never mind. We scrap this one. We will not. Okay, Edmund said no. All right. So we will scrap that one. Okay, so 11 and 12, we will leave it blank at the moment until we learn the energy chapter, then we'll come back. Okay, so 11 and 12, we will not look at it. We jump to question point number 13. Okay, point number 13. 13. Escape velocity is derived from the energy theorem. Okay, I'll give you the formula for escape velocity. In your textbook, you also got 2gm over r. OK， 这个是大 R， 大 R 跟小 R 是什么分别？大 R 是 planet 的 radius，planet 的 radius。OK， let's say Earth. If I want to find the escape velocity of the Earth, then I will use the mass of the Earth, the radius of the Earth, and this is the escape velocity EV of the Earth. 所以如果你要离开地球，你要走几块，你都可以算出来。我们用这个 formula。Okay, so V equals to 2 times 6.67 minus 11. Mass of the Earth 5.97乘10 24，这种是有给你的啦。Over radius of the Earth 6400 km， 所以我乘13 meter。Okay, you calculate that one and see what you get. Okay, you should get this 11155.15 meter per second. 换它去 km，因为它太大了，所以这个我可以换去12311.2 km per second。所以你要走几快？11.2 km 一秒。This is how fast you have to be traveling at if you want to escape the Earth's gravitational field. In 1 second, you need to travel 11 km vertically. Okay, so that is the escape velocity of Earth. 如果我讲其他的 planet, okay, the Sun, the Mars, the Jupiter, they all have different escape velocity, and you can calculate all of that. It depends on what? The parameter here depends on the mass and the radius. The bigger the planet, 哎呀，一下我的电脑要死了。The bigger the planet, the higher the escape velocity, okay, to escape it. Okay, next one, escape velocity of the sun. Okay, you calculate again the second one. Okay, so if you notice, this is the Earth. If I want to send the rocket in orbit, why the rocket go like this and not like this? 为什么它不是直直飞 until it escape the Earth? Then it will be traveling at this speed, right? To escape the Earth. But then the rocket wants to go like this. Like this is, we say, a parabola, a curve, or an ellipse. Why like this and not like this? Reason is because, what is the purpose of a rocket? Or maybe you want to send a satellite. Okay, you want to send a satellite in orbit, or you send a space shuttle, a rocket, anything. The purpose of the rocket is to achieve orbit, right? Sometimes you see the word, they want to achieve orbit. They want to achieve orbit. What does it mean by achieve orbit? They want to have a speed that is large enough to keep it going around the Earth like this. 记得我刚刚一来的时候讲到你的 linear speed 对吗？你的 linear speed 要到那个 required speed，你才可以绕地球转。Okay, let's say if this one is a tall mountain, you stand at the top of the tall mountain. You throw something. You throw it at first, it comes down like this. Like this. You throw it harder, it goes further and comes down. Harder again, it goes further out and then goes down like this. What if I keep increasing the speed? I keep increasing until it starts to go around like this. Like this, and then come back at the back of my head. What I do, I duck like this. If this object come to here and then I duck, then the object will continue forever going around like this. This is when we say it has achieved orbit. Okay, it has achieved orbit. So you slowly increase your velocity until it goes in orbit, achieving orbit. So this is what the rocket wants. Okay, this is what the rocket wants. So that means that is why the rocket, they tilt their motion. They do not go directly upward. They want to tilt their motion to the side like this. And then slowly they move. The gravity brings them horizontal like this. Okay, when they are moving like this, there's a gravity try to pull it down like this. Every time they go, the gravity pull it down, and eventually they go horizontal like this. And then they move like this. If the rocket goes like this, there's no point for the rocket, because what happened after you exit the atmosphere? What happened after you exit the gravitational field? Rocket goes like this. This is the gravitational field. This is where G is 0. You go vertical and then goes up. Then what's next? No point, right? So the rocket, 他们不要只是 escape the Earth. They want to achieve orbit. Okay, that's why they curve like this. And what is this speed called? Linear speed. Okay, linear speed. 所以当他们 achieve orbit 的时候，接下来做什么？他们就一直 run 了。如果你要 send, let's say you want to send something to the moon. You want to send something to the moon, how do you send the thing to the moon? You increase your linear speed, right? You increase your linear speed, then the satellite, they will climb higher altitude like this. Like this, and then eventually they reach the moon. Like this. This is how they send stuff to the moon using the orbit. Right? So all they need to do is to increase the linear speed. 你只是要 increase 你的 linear speed， 然后那个 gravity 会慢慢带你 spiral 这样子到 your destination, the moon here. If you want to send the satellite to Mars, okay, higher like this, same. They use this method. They call it what? Gravity assist. Gravity assist. Gravity assist. Why do you want to do this? Because straight away, if you send straight to the moon, can, but not practical. 因为你要装很多的油，你才可以去到月球。当你装这样多的油，你的重量太多，你飞不去。Okay, that's why they cannot straight go like this. 他们用什么 gravity assist. They use orbit to help them. Yes. All they need to do is to adjust the linear speed. They go out, they decrease the linear speed, you just spiral inward. You increase, you spiral out, outward. Okay? Right. Yes. So that is our lesson on the gravitation. Okay, take a rest, 2 minutes, and then I'll give you some exercises.